Okay, so we're going to do a short little video here to try and explain power factors. So what we have here is an IOTA DLS27-40. It's connected to an iCharger 3010. In between the IOTA and the iCharger is a simple little Astroflight watt meter, just connected here with Dean's cables. This is then plugged into a power strip. It's the IOTA power supply is the only thing in the power strip, and then you can see this goes into a kilowatt. And in the kilowatt here we can look at watts, volt amps, and then total amp draw, and then there's a bunch of other things that you can do here as well. But as you can see, right now sitting idle doing nothing, it's drawing about 19 watts. It's drawing about 40 volt amps. So let's go ahead and power this up. I have this connected to a couple of 10S packs. I have this set to charge at 30 amps. I won't actually get 30 amps out of it, but we'll go ahead and hit the charge button here and see what we get. Alright, we're powering up. So as you can see, the charger here is putting out about 26.4, 26.2 amps at about 38 volts. So if you multiply 26.2 by 38, doing that in my head, that's about 995 or so. So about 1,000 watts output. And you can see, by looking at the watt meter here, that we're taking about 37.2 amps in, 1,044 watts going from the power supply to the iCharger. So that's pretty efficient. It's only about 1,050 watts in for about 1,000 watts out, so you're only losing about 50 watts going through the charger. Now let's go ahead and look over here at the kilowatt. And what you see here, we're on watts. I don't know if you can read that, but it says watts. It's drawn close to 1,200 watts. Now if I click this over to volt amps, you see we're drawing about 1,700 volt amps. So the volt amps and the watts, very large difference there. And that's about 75-73%, somewhere in that range. I don't have a calculator, but you can certainly look at it. 1,210 watts or so, about 700 volt amps. And what you can see is if you look at the amp draw, we're drawing about 14 amps. So 14.2 amps. So in theory, if we were at a power factor of 1.0, 14 amps by 120 volts would be in the neighborhood of 1,700 usable watts, right? But as you can see, we're only getting about 1,200 usable watts out, and indeed if we look at volt amps, it is almost 1,700 volt amps. And the difference between the volt amps and the wattage is the power factor. So now the interesting thing here, if you look at the efficiency of this whole charging setup, just looking purely at wattage, is that drawing 1,200 watts and putting 1,000 watts of output through the entire charging system, that's fairly efficient. But when we look at it from a total amp draw perspective, and this is where the power factor comes in, what it means is you need a generator that can put out 14 amps. Now ideally, if we had a power factor corrected power supply, we should only need about 10 amps to support that, but unfortunately we are not power factor corrected, so we need closer to 14 amps. And this is where power supplies like the Meanwell and others really come into play. At some point I will try and do another video showing the difference between this setup and that. Okay, this time we're for round 2 of the same setup. This time, as you can see, we have a Meanwell RSP 1000-27 volt. Again, we're going to go ahead and have this hooked into the Astroflight watt meter here. See, this is then connecting to the iCharger, same as before. And again, in the power strip, the only thing connected is the power supply and then into the kilowatt. So as you can see, sitting idle here, we're drawing about 27 or so watts. So let me go ahead and go over to the charger. And again, we have this plugged into a couple of 10S packs, so we're going to go ahead and start the charge. Okay, so firing up, you can hear the fans on the power supply going here. So we're getting about 25 amps into 38.9 volts. I think that is somewhere around 975 watts, maybe a little bit more, into the batteries. And you can see here the power supply is putting out 1,025 watts, so it's actually putting out a little bit more than the rated 1,000 watts of power. Now the interesting thing here, if you go ahead and look at the kilowatt, watts going in is about 1,200 watts. But look at the volt amps. We're at about 1220 volt amps, 1215, 1220 watts, fluctuating a little bit there. And if I click on power factor, what you can see is we're at a power factor of 0.99, so we're very efficient. So if I go ahead and look at the amps now, the amps should be close to 10. And there we are, about 10.3 amps. Now if you remember, we were at about 14.5 amps on the iota, so clearly we're much more efficient from an amp draw perspective for just about the same power output. Before we were at about 995, here we're at about 975, so pretty close. But notice how much more efficient we are on the amp draw. So 10.3 amps, drawing about 1200 watts, and about, again, 1200 volt amps. And you can see those two numbers are almost exactly the same, again, because the power factor is now 1.0.